All right, so for a titration, we just have a flask and we're going to drip something in it. First, you have to have the phrasing right. So if you read the problem, it says of HCl, the titration of something is what's in the flask. So HCl is what's in the flask, and with is what is going to be dropped into the flask. Now, the way these titrations work is they'll ask you about this series of reactions over a period of time. So like the first one's always the pH is 0, and then they'll do some pH a little ways in, and then you'll have, I don't know, so let's just say the pH at sometime. Then you have the pH at equilibrium, and then finally you have the pH when you've gone past equilibrium and all that's less than flask is OH. So that's how this is going to work on this one. So we're going to start with the before the addition of the base, and then we're going to go through the different phases of it. So in this case, it's just the pH of that concentration right there. So we'll just do the negative log of 0.4. It doesn't matter if you got one drop of it or tons of drops of it. It's just going to all be the same pH when you're just dealing with one substance. So that gives us that the pH is extremely acidic. That would kind of be accepted with that kind of concentration. It's almost 0, right? 0.397. And that's all. Now for the weak acid, weak base, you would have to do a nice chart for that one. All right, so let's look at the 50 milliliters of base. So this is before equivalence point. You would have to do an ICF chart for this because we've got to figure out how much of the base and acid, how much of each of them is left. I have to convert them into moles, so 0.035. Now that's because it was in milliliters. I'm converting it in my head into liters. And then my molarity, remember it's moles per liter, so 0.40 moles in 1 liter, and that's for the HCl part. And then I also need to do the base. So it's saying I have 50 mils, so again, in liters, that's 0.050 liters. And then I go over and I look at the concentration. It's in the problem, it's that 0.2 number. So 0.2 moles of NaOH in 1 liter. So I just got to solve both of these. So this one times the 0.4 gives me 0.014. And this other one is going to give me 0.01. And by the way, I'm going to use these exact same numbers in the next titration. So I'll be just copying and pasting these numbers into the next titration. So this is solving for moles. I don't have to keep solving for it over and over. So I'm setting up the ICF chart, HCl plus NaOH, and then I've got my product and my H2O. Initially, I've got 0.014 for my HCl and 0.01, and then I don't have any of my product because they haven't happened yet. Now the 0.01 is the smaller of the two numbers between that and the 0.014, right? So I'm going to subtract that 0.01 from the 0.014. Well, I'm just going to subtract it on both sides from both the left, and then I'm adding it to the right-hand side. And this all works because this is all 1 molar. It would be a little more complicated if I had a 2 in front of something somewhere, but you're not going to get that situation. And you can see how we end up with 0.004 on the left and 0.01 on the right. Now remember that the pH of the Na part is going to be 7 and the pH of the Cl part is going to be 7, so it doesn't count towards the pH, and that's what we're trying to figure out. Now before you get too crazy, look, we've got to figure out the volume. We can't just put a mole amount in. So we had 50 and 35. This is how many milliliters we've got. So we've got to take that and divide it right there by liters to get that into a molarity. Now I can use negative log of that amount to figure out my pH. So my pH is 1.327. So like I said, I've taken the negative log of this quantity here, and I get that pH. Now we're going to go on and we're going to look at the 70 milliliters of base. That's actually at equivalence. So we're going to take, you'll notice this number hasn't changed the whole time. It's because our acid is just always there. So we don't have to recalculate the acid, but we do have to change the base number. 0.070 liters times, again, that's our molarity of the base at the very beginning of the problem, in 1 liter. And that's going to give us, I don't know if you can see the 2 times the 7, that's going to be our same exact number. So that's what equivalence is when your two concentrations, when your moles of both of them are the same. So when we write our ICF chart here, you're going to see that we make the NaCl and then plus the water, and we've got the 0.14 and the 0.14 and 0, and we're just going to subtract both of those. So I don't have anything of either of those. And I made NaCl, but the NaCl, both parts of it, you're going to see, I made that same amount of NaCl. But that Na becomes with a pH of 7, and the Cl has a pH of 7. So that one doesn't matter either, and the whole thing is going to be neutral. Okay, so then we have the very last point. Now this is where it's like all base, like we've run out of acid and the base is just going to rule the show here. So I'm going to just set up this ice chart and copy this down, but these numbers are going to be all the same again for the HCl. But our NaOH, it's going to be the 0.080 liters is what that one's going to be, times the 0.2 moles of NaOH. 2 times 8 is 16, so that's 0.016. All right, so we're writing out the equation over here. HCl plus NaOH goes to NaCl plus H2O. The 0.014 stays. Then we have the 0.016 and 0 product to start with. Notice the HCl is now finally the smaller number. That's the number we're going to subtract from both at this point, 0.014. And we have 0.02. We do make some NaCl, but remember we already said that that was neutral, so it's not going to matter. Then we do notice that we're now talking about NaOH, so we're going to be talking about POH. And again, I've got to do that as a molarity. So I'm adding my total volumes together on the other side. So I've got, looks like about 115 when I add 80 and 35. So I need to take my moles of NaOH divided by 0.115, which is the liters form of it. And I'm going to calculate that in my calculator. So I've got negative log of 0.002 divided by 0.115. So that is my POH. Now remember, I actually am looking for pH, so 14 minus that number, and that gives me my 12.2 number. And you've gone through the whole titration for a strong acid and a strong base. Woohoo!